Hi everyone, thanks for taking the time today. So I'm indeed Guy Podjarny, or Guypo, founder of Snyk before, founder of Tesla now, more relevant here. And I want to talk a little bit about the future of software development, what we call AI native software development, and how it might look. So let me start a little bit by talking a little bit about creating software with LLMs today. So today, it's pretty magical. I still get excited by creating, making an ask for an LLM and having it create a thing and it actually working. And so this is an example of an ask I made just the other day from Anthropic in this case, saying, hey, can you create a simple to-do app for me? The code should be no more than half a page. I wanted it concise to screenshot here for the presentation. Can you do that? And it complied and got me a little to-do app on it, which was pretty cool. Except, as you might expect, the add button didn't work. So it's okay, it's a to-do app. Why do you need the add button to work? I said, okay, fine. Claude, the add button doesn't work. Clicking add does nothing, and went to work, fixed it, and created a to-do list that the add button does work. There's another subtle change that has happened here. Anybody noticed? Why did the button color change? I told it to make the add button work. There was never an ask or a statement about the color. But then you kind of stop to think about it. So well, where did I ever ask it to make the button color? Where was this decision even made? Where is it captured? The answer really is it's captured in code. If you look at the code, not quite half a page, but sort of the sufficiently succinct code, somewhere in there it says BG Blue 500, and it made that decision. When I asked the Claude to fix the code, to fix the add button, it ended up writing totally different code, and it happened to inherit from some component that happens to be black. And all of these are random decisions. They're a part of that dice roll, but they also represent kind of reality today when we think about software development. Where are decisions? Where is this information kept in your elaborate application? Where does it say the button should be blue? Over time, the answer is in the code. So let's take a sidestep there, talk about software development as it stands today. And today's software development is very code-centric. You get some requirements, you write some code, you make 100 decisions that never make it back, never make it out into the system. You take that code, you package it up so people can use the software, and then hopefully somewhere in the process you've written some docs and you've created some tests, and they are almost always partial. They do not kind of fully cover what you've done because they're a chore. They're sort of a lot of work. Over the long run, the only asset of these that really stands the test of time is the code. Over time, you get some more enhancements and you write some more code. You get some bug fixes and they add some more code that lumps on. You get some edge cases, sort of forces some contorting. And how do you create some additional code? You have a migration to a new framework that really makes you do unnatural things. And eventually, you have a pile of code. And a year later, good luck trying to find the trace of requirements and bug fixes and enhancements and definitions that says what was the ask, what should the application do. What we really have is we have the code. The code is the asset that stands the test of time. And this code couples within it what the application does and how it works, and it tries to capture this information in the tests and in the documentation. It tries to say, hey, the docs describe what the app does, and the tests capture some of concrete examples to know that it doesn't regress. But as the application grows and the application kind of gets more sort of elaborate and detailed, generally, the docs and the tests, they're a chore. They basically fall out of repair. They're decorative. The docs are really just descriptive. The tests as well, there's no natural forcing function to require that you keep them out of pace. And they end up naturally remaining partial, more and more partial. That in turn makes the application fragile. And I think we've sort of all seen this with software development projects. The code inside of it holds, the code is the implementation, it's how the application works, but in the same lines, it hides what the application does, that the button is blue or what happens when you click it. And every time you change the code, you change the implementation, the how, which you have to do because your code lives in a dynamic environment, right? The dependencies change, environments change. Even if you're not evolving the application, you carry the risk of breaking the what, of breaking what the application does, which is not captured anywhere, does not have some sort of forcing function. And so the application becomes fragile. And there's these parts of the code that if you haven't been in the company for 3 years, or if you haven't talked to Macy before, like, you cannot change this code because, you know, someone knows where the sort of the traps are. And areas that really are the bane of existence, you try to avoid them and you end up writing code around them even though it's unnatural because you really don't want to touch that code. And that becomes hard. And eventually, practically every software development project gets to this point where it becomes a maintenance nightmare. And you need to either decomp it or sort of overhaul it or re-platform it. That's sort of one inevitability. Or it just becomes this, like, do not touch this. And this keep the lights on, the KTLO budget becomes greater and greater. So this is kind of the sad reality of sort of software development today. And it's powerful that it centers around the code, but it's problematic that the code couples those things. When you look at AI dev tools and how they try to help that problem, they really don't change this up. As we've seen before, they create code and they make all of these steps a little bit easier, sometimes a lot easier. Make it easier to create code, easier to create docs, easier to do a migration, and eventually all of their output comes into the code. And the code continues to dominate as the only long-lived asset. And we think that this is not the true potential of AI. That this is working within the existing workflow and trying to automate pieces of it, while the true potential is if you really rethought the workflow and you thought, how can I, in the advent of this powerful new technology, how can I really rethink what software development is? And our view is that the answer is that software development will move from being code-centric to being spec-centric. What does this mean? It means taking these requirements and moving them from being something that is disposable, that came at the beginning and disappeared, to being the thing that is at the center and long-lived. And in fact, not just the requirements, but rather package them up with the test to create something that is a spec, something that says, this is the definition of what my application is supposed to do. Here are some tests that would validate that it is correct, that would look at the generated code that it is correct, and conform or confirm that it conforms to the spec. And the code will become a generated artifact, will become a build artifact. It will be generated to satisfy the needs of those requirements, and will become increasingly immutable, disposable. Just like in the cloud, we've gone from like managing your servers to make an API call and generate the code, and get yourself a server. In this case, you'd sort of make an API call and you would generate the code. And just as a small side note, the docs will be the same. They will move from being something that is decorative to something that is constantly descriptive. So even as a consumer of the software, you would have now something that is more reliable, that describes your system, because it would also be generated. So really the asset that would live over time would be this definition of what the application does, and the thing that will be adapted every time by the LLM will become the thing that changes and morphs. Why is this possible? Like why are we claiming that this is a capability? Well, it comes down to 3 core capabilities that the LLMs unlock. The first is that LLMs make it easier than ever to describe what you want. You can just say those. You don't need fancy, funky formats, you know, the 25th open source standard to how do you define an application. You can just say what you want. The second, maybe quite obvious, is that machines can write code now. And that's amazing and magical, as we talked about before. And the third, that's probably not as discussed, is that LLMs can fill in the gaps. If before, when you think about BDD and TDD, you think about behavioral definition, you'd have to say every little bit, every small decision that the application needs to do. Now you can let the LLM decide. You can say, create a tic-tac-toe game without calling out what the rules of tic-tac-toe are. And that's amazing and scary and an opportunity and a problem that we need to address. But it does allow specs to suddenly be viable. It suddenly means you don't need these like overly painful formal specs to write, nor do you need to create no-code sort of toys that all decisions have already been made and you're just assembling Lego blocks which do not necessarily enable innovation. So LLMs make specs practical. So this is sort of our core thesis, and we'll talk about the questions, but maybe let's talk a little bit about why is this a worthy endeavor? Like, why do we care to try and do this? If we had this spec-centric development, we had the spec in this generation, what could we do? So there's a bunch, there's a lot for that. First advantage of what we call, and sorry, I should say, we call this practice AI native software development, or AI native development for short. And what are its advantages? Well, the first is that software is less fragile. So this is really addressing directly the problem we talked about before. When you want to make a change, you don't risk whether you're going to break the what or not. That is the core. And so you make a functional change to the spec, and then the code gets generated and validated against the spec. So you always know that your application will conform to the spec by the very definition of how it's created. The second is that the software will be adaptable to different contexts. In practice, when you generate the code, it doesn't just take in the spec. It takes in the spec and the context. What is the context? Well, it can be many things, and we'll talk about that some more. But it could, for instance, be wanting to create this in JavaScript or in Python, and you can just generate that. Or wanting it to run on AWS or on GCP, or things that are more elaborate than that, best practices for the ecosystem. Some of that is already encoded in the models themselves, and some of that can be provided outside. And so suddenly software can adapt to its surroundings and to your specific environment much faster. Again, somewhat like cloud elasticity. And the big unlock from both of those is that you create software that is autonomously maintained. Because maintenance, by definition, is change the code without changing the spec. Just change it so that it works with this new operating system version, or this new framework, or this service API that I'm using has changed, or I know that this library is now vulnerable. Just change it so it upgrades and works with it, but do not change how the application behaves. And the problem with maintenance is software is fragile. You don't know what is the application supposed to do. In this situation, you have that. So all you do is you change the context. I have a new operating system, and you generate the new code. All of these just are elaborate, and we'll talk about the challenges here, but that's the opportunity. And autonomous maintenance is a big, big unlock in terms of developer productivity and software health and security and more. Another big chunk of advantages is around the dynamic nature of software. So if software is so easy to produce and adapt, you open up all these new opportunities. You can create customizable software in which you might have created a piece of open source software, but an enterprise that is running it tunes it to their specific infrastructure, to their specific environments, to their budget, to their business needs. And there's a lot to play with here about which decisions do you delegate to the LLM. The LLM should get better and better. The platform should get better and better at filling in the gaps, at you saying less or providing information in the context, and the LLM getting it right. But you can sort of see the opportunity to provide that sort of input of where do I want this to run, and therefore create the code that is right for the surrounding. And this can go all the way eventually to personalized software, in which that context software is so dynamic that users can provide their preferences when they use the system, and the system can adapt itself to that environment. And then the last bracket is you really can think about how software will just become better, the code and the quality that it creates. It can use a sequence of probabilistic optimizations, once again building on LLMs, to say, hey, make the code more secure, make it faster, make it more accessible, make it localized, and every time validate it back to the spec. And the result of that is higher quality software. If that's not enough, you can go past the build process into deployment, and you can loop observability into it and look at telemetry and how the software runs and use that information to tune and improve the optimization. Always, always, always verifying that it conforms to the spec. So you really, another way to think about this a little bit is you get in this spec this slider that allows you to control how predictable versus how adaptable you want your software to be. In the spec, you write where is it that you want it to be predictable. And in this context, you provided the ability to become adaptable to whatever surrounding that you want. And last but not least, which we care about especially in the open context, is that it will make software development a lot more inclusive. And this is in part already happening with LLMs today, but LLMs today, as we've seen before, they're limited to what you can manually verify, to these tiny apps that you can click all the buttons and see that they work, or to people who can verify the code and look at the code, because eventually that's how they validate it. And we think this type of spec-centric development will open it up to a lot more people, because many, many more people can say what they want than actually satisfy how. So this is I guess the bottom line of this is that we think AI native development unlocks easy creation, allows us to tap into this LLM magic while providing us with strong controls, allowing us to have what we need to be able to build and grow software to something of substantial size. So a bunch of these things that I said are hand-wavy and actually very hard, like easy to say, hard to do. And there's a whole bunch of open questions. Probably the most obvious ones are, what is this magical spec you speak of? Like what is it's a spec. What does a spec look like? What is this validation that we talk about? How does this even look? And those are good questions, and we'll talk a second, a bit of an example, but we have to expand that, we have to elaborate that. We also expect there will be multiple answers to that. For instance, the way you would spec out a mobile game will be different than how you would spec out a pacemaker, than how you would spec a SaaS application. These things probably require some standards, some expansions, some variations, and the validations with it. You go on to say, well, how do I, if I didn't write the code, inevitably sometimes it would go wrong. How do I debug a system like that? How do I observe it in runtime? So we have to answer that. There's interesting questions about how do you engage with these decisions the LLM has made. You've delegated some decisions and the LLM filled in the gaps. How do you know what it's decided? How do you scrutinize what that is? You said I want a button, the LLM decided that it's going to be red. First, how do you find out? Maybe this is a visible example, but some are not visible. And maybe you say, fine, I don't care. It's okay that it be red, but you don't want the color to change from version to version. So how do you persist that LLM decision? How do you make it so that it doesn't, that you have some predictability in the decision, even if the LLM has made that decision? How do you version software that is adaptable? How do we think about this from a software practice perspective? And maybe most importantly, where's the human role over here? What does a person do? What is an AI native developer? And we envision people and software developers to really become less and less coders and more either kind of evolving towards the product side and talking about understanding the user empathy and the user needs, or evolving more towards the architecture side and understanding what are the trade-offs. Do I want to optimize for this one cloud, or do I want to be multi-cloud? Do I want simplicity, or do I want extensibility? A lot of these trade-offs that are not, they're binary, they're choices, they're tastes, they're preferences, and they're dependent on the developer's ability to understand the context, the business they're in, and say, how do I want this to evolve? So all of those combine into our view, which is that AI native development isn't just another abstract language or something like that, but rather a new development paradigm. When you envision software development or all of these steps, they start looking very, very different to software development today. So we're trying to answer a bunch of those questions at Tessel. Here's a loose example, it's a bit small font of it, of when we're working on it, what we think the spec is. We think it's maybe a hierarchical set of capabilities, and each of those has tests associated with it. And so when you generate it, you can see them and you can see where it fails. And there's a lot of work. This is a simplified part of the screen that we have because otherwise it'll take up time. But there's a lot of work that we're doing it. If you want to get a bit of a taste of working with specs versus prompts in those chats, Simon and Macy are going to be running a workshop at 1 p.m., 1:15 p.m., assuming we're on schedule. And they'll let you play a bit with this. The product itself is not yet out. However, it's important for us that this paradigm is not something that a company comes along. We think this whole thing is much bigger than Tessel. We think, I've not said Tessel throughout, and I think this is the nature of where software development will go. We're trying to help it, but we think it is critical that it will become an open, collaborative process. When you think about AI, you can imagine a future in which there's this big brain, you kind of have this one platform that just absorbs knowledge and information, and you make an ask of it, and you kind of keep your fingers, cross your fingers and hope that it gets it right, and it just gets smarter and smarter. And the question is, in that concept, where is the distributed innovation? When you have a brilliant idea, but you're not the one that is the owner of that brain, how do you come into play? And as an ecosystem, how do we grow? We'd very much prefer and believe the winning platform would be, or the winning approach will be, a place that is more composable, that can bring together these different steps, as I've shown, from different innovations, from different people that consume the software can compose it and can design it to their needs and their environments. And so we think it's critical that we build a lot of these concepts and these practices as a community. We have the AI native developer community platform for it. We have a podcast, we're running a conference, we have an ongoing kind of live community. The goal here is to people to share opinions, to try things out, to share their experiences when they've tried a thing, to share their tools and their pieces of this puzzle, and to have that be very long-lived and be a community effort. So I'd encourage all of you to join that community and voice your opinion and kind of help us sort of shape the future of software development. Thank you.